So now moving on to the exercise. So I thought it would be best if I show you how to work around with this, because at first it may be a bit more difficult to actually visually see how to do it. So here's an example for you. So let's have a look at page 314, example number 7, and we'll move to example 8, which continues on from example 7. So let's have a look at the question. It is claimed that when this pair of citrus dice is thrown, notice that the pair shown are not normal blueprint of normal dice. Because if you have a look, there's 1, 2, 3, 4, and then stops. There's no 5 and 6 here. And there's a repeated number, and on the right one, a B, it goes all the way up to 8. So it's not a normal die. So it's a different pair, and they're called citrus dice. Now, if we roll this and two numbers are obtained added together, so whatever the dice land on and then we add the number up, and that would be the new number, the probability of each trial is just the same as if the two dice were numbered with 1, 2, 3, 4, and 5, the normal one. Verify this claim. So what does this mean? It means with these pair A, B, and we roll it, and let's say one landed on 2 and one landed on 8. We add it up, and the number is 10. Imagine we had another pair of normal die, two normal dice, from 1 to 6, and we throw it, and we land on 6 and 6. It becomes a 12. The possibility of the numbers, the sum, from throwing are the same. Now, it may be a bit difficult to kind of understand that and to prove that and to verify this claim is true. So this claim is checking if this event is, or possibility of this event is the same. Let's have a look. So what I'm going to do, I've already done this for you, as in like I've already drew. Whoopsie. I already set out the table for you. So as you can see, I have on the left hand side, this is pair of citrus dice. On the row at the top in black, we have dice A, 1, 2, 2, 3, 3, 4, all the possible outcomes. So 1, 2, 2, 1, 2, 2, 3, 3, 4. So the sample space of A has been written down on the row at the top. And sample space for B, 1, 3, 4, 5, 6, 8 have been written vertically on the left column in black. Now what I'm going to do is I'm going to now add those numbers up and then show it into this table format, which is similar to like the multiplication table and addition table we had in our mathematical book when we were in lower years at the back of our red book. It's similar to that, but this is a addition table where you just add one number from the column with the corresponding row. And this is what you will get. You would have spent some time to write this down. It's just that I already did, and then I just skipped the process, so we shortened this video. It is important though when you do it that you don't rush it, because if you make a mistake and accidentally write a wrong data, it will screw up everything for your future questions. So it is important that you take time and be careful when drawing the diagram, because all your results will rely on it. So let's have a look. So on the left side we have citrus dice, and on the right side we have normal dice. Just looking at this, how many possible outcomes are there? We can see that I'm looking at the red numbers, the sums. It is a table of 6 by 6, and therefore there are 36 possible outcomes for citrus dice. And likewise for normal dice, it's also 6 by 6, so there are also 36 possible outcomes. The next thing is we are going to check the probability of the sum of two dice being n. And the way we're going to represent it is P of the sum being a specific number, n. Someone may ask, why is this S when in the textbook example it's T, and does that matter? The answer is no, it does not matter. It's just a way to say that it's a sum. I used sum, which is why I wrote down S, but in the textbook example they used the term total, which is basically the same stuff, which is why they use capital T instead of capital S, but it does not change the result. So this is my mathematical notation. So whenever I write something like this, that is what I mean. It means probability of the sum being 2 is what that notation means. Whoops. So let's have a look. Let's first start by the probability of the sum being 2. So the way we represent it is n of 2 over n of u. This is what we did last lesson, and that means the number of the outcome being 2 all over the number of the sample space. And we know that the number of sample space is 36 because we just checked earlier that there are a total of 36 possible outcomes. Now the number of 2 occurring 2, we have to go back to the data table and count how many 2's there are in total. We can see that there's only 1. Therefore, n of 2 would be 1. Let's continue. Let's have a look at P of S of 3. Number of 3 occurrence all over 36. So everything will be over 36 because there are 36 possible options. Let's count 3's. We have 1 and 2. So that's 2 out of 36, which can be simplified to 1 over 18. Let's have a look at 4. We have 1, 2, 3. So that is 3 out of 36. That is 1 over 13. Move on to 5. We're just going to count how many 5's there are. 1, 2, 3, and 4. So we have 4 5's in total. So we go 4 over 36. And we can simplify this to 1 over 9. And we can continue on with this process for P of S of 6, P of S of 7, and so on until the biggest number being 12, P of S being 12. Now let's have a look at the pair of normal dice. Pair of normal dice, I have altered this as S with a little subscript n to say it's the sum for the normal dice, because otherwise we won't be able to tell the difference of this one and this one if they're all written the same when they're clearly different. Remember at the beginning how I mentioned about the importance of communicating clearly? This is what I mean. Alright, so let's have a look. So two occurrences only once. One more time. So this will be again 1 over 36. And everything will be over 36 as well because there are 36 possible outcomes. Let's count 3. We have 1, 2. So 2 out of 36, which is 1 over 18. Let's have a look at 4. 1, 2, 3. 3 out of 36, which is 1 over 12. And normal dice pair is quite easy to see from this diagram that it's all this diagonal line. So 5, we have 4 5's, we have 5 6's, and so on. So for 5, it will be 4, 1 over 9. And it will be continuing. Let's have a look. Oops, I made a mistake here. So 1 over 12. Shall we compare the probability? We had 1 over 36, 1 over 36, 1 over 18, 1 over 18, 1 over 12, 1 over 12. So they are identical. So from that, we can verify that this is actually true, that this claim has been verified. Now, let's move on to example 8. Example 8 uses the same example from example 7 that we're using the Sichuan. And once again, I have written down the table already for you. Now the question asks you, use the sample space diagram in example 7 to find the probability that the total found by throwing 2 Sichuan dice is at most A. Let's start with that. At most 4, sorry, not A. So that is 1, 2, 3, 4. Actually, there would be no 1 because there's no 1 in the data set. So what we do now is with a highlighter, we highlight all the possible outcomes that makes this event true, which is 2, 3, and 4. 2, 3, 3, 4, 4, 4. So what makes this event true? What is the probability of the sum being at most 4? It is 1, 2, 3, 4, 5, 6 outcomes in total out of 36 possibility. So that is 1 over 6. That's the first one. Let's have a look at B. B is a factor of 24. A factor of 24. Now, how do we know what factors of 24s are? I'll show you how to do a factor long division. So what I do is I write down the number, I do long division side upside down, and then I start with a small prime number such as 2 or 3 or 5. 24 is an even number, so I divide it by 2 whenever it's an even number. 24 divided by 2 is 12. 12 is another even number, so I divide it by 2 again. 6. And 6 is another even number, so I divide it by 2 again. And 3. Now 3 is a prime number. It can only be divided by 3, so I can just stop there. I stop whenever there's a prime number. So I now have a look at all the numbers on the left-hand column. Therefore, I say 24 is 2 times 2 times 2 times 3. And therefore, the factors are 22 and 3. So what I'm going to do now is I'm going to highlight the next event, which is 2 and 3, from this data set. We have 1, 2, 3, only 3, right? Because there's only 2 and 3. So the probability of the sum being a factor of 24 is 3 out of 36, which is 1 over 12. Last but not least, C, which is at least 8. At least 8 means it's a set of 8 and above. And we have only up to 12, so I'll go to 12. So this event, I'm going to highlight with green, is 8 to 12. So now I'm going to highlight 8 to 12. Okay, so how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 15 in total. Yeah, 15 in total. So probability of S being at least 8 is 15 out of 36. This can be simplified to 5 over 6. So we have just completed example number 7, example number 8. I would now like you to stop this video and try yourself exercise 4D question 1 and 3. Good luck.